Howdy, howdy. Let's take a look at Lewis dot structures. I know the last video we said we were going to get into Lewis dot structures, and we didn't because we ran out of time. But now we're going to get right on into them. Okay, I think you're actually going to enjoy Lewis dot structures. Once you once you understand the concept, Lewis dot structures are really easy to do. So the first thing that we need to do, there's Lewis dot structures of atoms, there's Lewis dot structures of ionic compounds, and there's Lewis dot structures of covalent compounds. Okay, we're going to start at the most basic one, which is the Lewis dot structure of atoms and ions. Okay, to draw a Lewis dot structure for atoms, all you're going to do is you're going to pretend that there's a little imaginary square around your element symbol. Okay, then you're going to start placing valence electrons around it, putting one electron on each side of the square until you've gotten on all four sides one electron. Then you can go back and double up. Okay, that's Hund's rule. Okay, don't forget Hund's rule. You can only put one electron in each orbital. Well, same sort of idea here. You can only put one electron in each spot. Then you can come back and double up. Okay, when you're doing the Lewis dot structure of an ion, you have to think about is this a metal or a non-metal? Okay, the reason it's important to understand if it's a metal or a non-metal, if it's a metal, then we know metals are losers, and that metal is going to lose all of its electrons. Okay, or some of its electrons, depending on what ion it is. If it is a non-metal, it's a gainer, and so it's going to gain electrons. Either way, you have to put brackets and a charge onto an atom for a Lewis dot structure, okay, or for an ion. So let's go ahead and do some examples here. So the first example we're going to do is really easy, okay? It's going to be lithium, and lithium is going to have, first off, we're going to put its element symbol, which is Li. And then remember, we're going to pretend like there's a box around this, okay? We're not going to actually draw the box, but we're going to pretend like there's a box around this. What we need to do now is we need to look on the periodic table, find out where lithium is. We see that lithium's in group 1. Since lithium's in group 1, we know that it has one valence electron, so I'm going to put just one little valence electron out there on the side. Could it go on top? Could it go on either side or on the bottom? Sure, it doesn't matter what side you put it on, okay? Now, if lithium becomes an ion, what's going to happen? Well, lithium's going to lose this one electron. Electrons are negatively charged, so if it loses a negatively charged ion, or a negatively charged electron, it's going to become a positively charged ion. So what I'm going to do now is I'm going to put lithium in brackets, okay? I'm not going to show any electrons because it lost its electron. So if it lost it, I'm not going to show it, and I'm going to put its plus charge. Okay, let's go ahead and move on down here to oxygen. Oxygen's element symbol is O. Okay, oxygen is in group 16, way over there. Okay, so oxygen's in group 16. So what we're going to do is we're going to say, okay, it's in group 16. So there's 6 valence electrons. So now I'm going to start placing my valence electrons. 1, 2, 3, 4. Now I've gotten all 4 sides of the square. Now I'm going to go back and start doubling up. 5 and 6. So this would be the Lewis dot structure of oxygen. Now an oxide ion, we have to say, okay, oxygen is a non-metal, so it's a gainer. So we know it's going to gain electrons. Now it's going to gain electrons until it fills its valence shell. Okay, its valence shell is its outermost shell, and its outermost shell can hold 8 electrons. So we're going to continue to fill this up until we get 8 electrons. So I'm going to draw the same one I had, okay, oxygen with 1, 2, 3, 4, 5, 6 electrons. And now I'm going to draw in the electrons that it gains as well. So of course oxygen is going to gain 2 electrons. We're going to put brackets around it and give it a charge. Now, it gained 2 electrons, so since it gained 2 electrons and electrons are negatively charged, it's going to end up with a 2 minus charge. Okay? Let's look at a couple more here. Let's do bismuth plus 3, okay? Now, the normal Lewis dot structure of bismuth is in group 15, okay? Since it's in group 15, we know that it's going to have 1, 2, 3, 4, 5 valence electrons. Now, we need to be careful with its ion, because its ion, it says that it forms a +3 ion. Well, we know that bismuth can form a +3 or a +5 ion. In this case, it's forming a +3. So what that means for us is that it's going to lose 3 electrons. So now the question is, what 3 is it going to lose? It needs to lose one of these 2 electrons here. So let's say it's going to lose this one. So we're going to get rid of that one, and then we can just pick any of the other 2. Okay, so now it's going to get rid of those 3 electrons to form this ion, bismuth. Now it still has 2 electrons. Okay, it still has 2 electrons because it only formed a +3 ion. So we're still going to put it in brackets, and we're still going to give it a charge. Okay, so that's the idea behind the Lewis dot structures of atoms and the Lewis dot structures of ions. Let's go ahead and do these last 2 here. These last 2 are a little on the trickier side, or xenon's not, but helium is. Excuse me. So let's take a look at xenon. Xenon is in group 18. It's a noble gas. And so noble gases, we know, they have a full octet. Okay, they have a full valence shell, which also means that it has 8 electrons. And since it's in group 18, last digit, we know that group 18 is going to have 8 electrons. So I'm going to give this 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay, so now can xenon form an ion? Of course, it's not going to form an ion because it already has a full valence shell. Okay, it doesn't have to become isoelectronic with anyone because it already has a full valence shell. Okay, so now let's do helium. Now remember, helium is way up here on the periodic table. Okay, it's way up there. So with helium's going to be a bit of a weird one, because if we draw the electron configuration of helium, it's only 1s2. Okay, that's the electron configuration for helium. So what that tells me is that there's no p electrons at all. There's only s electrons. So it has 2 electrons, but instead of splitting them up, okay, these 2 electrons, they're already, if I was to draw orbital notation, okay, and I draw the arrow and the little lines and this thing, okay, if I were to draw an orbital notation for this, it would just be that right there. Okay, there's only 2 electrons in helium. So what that means for me is that I am going to give it 2 electrons, but they need to stay together. Okay, and so there's our Lewis dot structure for helium. Okay, so that's the beginning of it. That's the beginning of Lewis dot structures. We've got a lot more to do. We're going to see on the next video how to draw a Lewis dot structure of ionic compounds, and also how to draw Lewis dot structures of covalent compounds will be coming up this unit as well. So keep practicing. If I were y'all, I'd go ahead and try to practice all the rest of these on your own to make sure that you know what's going on. Appreciate you.